Okay, so here we have this other landscape. This is the grassland. So we see grama, right? We characterize the grama as the Colorado state grass. This is the co-dominant species. This is what the tie that binds. When we talk about climate change and how there is the largest carbon sink on the planet is the grassland, it's this. It's blue grama in Colorado and the soil beneath it and all of the root biomass. All the carbon stored in here represents storage, right? And fossil fuels are stored, but when we combust them, they become a source, and the carbon moves into a smaller molecular shape, right? It's CO2. It's just 3 atoms. It's not a like hydro chain, a carbon chain with many, many, many atoms. But the reason why fossil fuels have a lot of energy is because they have all those bonds, right? So you're taking large molecules, turning them into smaller molecules. That goes from carbon sink to carbon source. But the National Revegetation Strategy is afoot, and we have come to realize that the more we revegetate, the more we can put that carbon back into the landscape. We can bring it back into a large molecular shape. But as land managers, right, we want to talk to people about, now we're going to transition, and instead of talking about forestry, we're talking about range management. And so a measurement in range management is percent bare ground. And so it's helpful that this is all blue grama right here. We might encounter some other forb species like little flowers or other grasses, but largely it's blue grama, and you could say the landscape is dominated by blue grama without even measuring it, but you would want to measure that. But today let's focus on the bare ground concept. And so we are going to use these quadrats, and these quadrats here, notice how this is more appropriate for grassland, right? You don't want to use a meter tape. That's not going to give us anything when we're looking at the grasses. We might use the meter tape to create the area, right? So 15 square feet, set that out, right? Then you could look in there. But if you wanted to know like percent bare ground in 15 square feet, like how, this thing would have to be huge. So instead we have something like this is 2 square feet. And so if you look in here, it's like 12 rows by 9 rows. And in all my years of doing ecological measurements, I have finally landed on the easiest quadrant to make. It's PVC pipe. You saw that I could break it down, roll it up in my bag. And I just love using the construction fence because it doesn't matter what the area of the inside cell is unless you're going to do some complex ecological measurements. But for the land management purpose, you just want to know how many squares have roots and how many squares are bare ground. And then you'll be able to say, like, your range has 50% bare ground. And then you can use that measurement to say, like, you need to revegetate or it's looking good. And in the Garden of the Gods, my revegetation research has indicated that the referent community is roughly 55% bare ground. But, out east in other landscapes, it might be a different referent. But that's what it is, pretty close to here. So let's just say we want to wonder, is it at least 55%? Because we want to make a recommendation to the Bear Creek Nature Center, like, do they need to revegetate this landscape? So we'll do the same exact thing that we just did, but the area is already spoken for, and the measurement concept is already spoken for. You're going to measure how many squares there are total, and you're going to count it and figure out how many squares have grass rooted in it. And then the fraction is the percent cover, or percent vegetation, percent bare ground. Do not count the squares that have the PVC running through it. And yeah, we'll go from there.
How many of these are we doing?
We'll go through the same process. So one group can tell us, what did you do? What did you find out?
We did 2 random quadrats. The first one had 27 out of 108 squares with root coverage, and the second had 65 out of 108 squares with root coverage, which averaged out to, we had 43% coverage in our tube.
Wow. Okay, next group.
Okay, we did pretty much the same method. Our first plot was 47 out of the 108 squares had root cover. The second one had 53 out of 108 squares. Those were 44% and 49% coverage, respectively.
Now, could someone take out their phone and take all those measurements and put them into one average?
Sure. What were yours?
We had 43% overall.
Okay.
Do you want all four averages?
45% for an average for everybody's.
Okay. All right, folks. So, let's. What questions remain from that experience?
Oh yeah, is it just the amount of matter below the square that's rooted, or is it like the amount that's foliated as well?
Well, that's a great question. So in this particular landscape, I find that just the root cover is important to measure, but you can take cover in a forest and you can take a cover in many different ways. So if it was a woody stem environment, probably you would do canopy, and you can measure the canopy cover. And in this case, again, a photo would work great for this because we could lay the plot down or have someone hold it, suspend it right over the vegetation, and just take a picture and see, is there shadows in the squares? Or do we see the vegetation? But as soon as you lay the quadrat down, you kind of mess that up.
Yeah, because it bent like a lot of the stems over, and so I had to like feel to make sure there's actual roots underneath it.
Yeah, and that is a good point too. Like just touching it helps to increase the reliability of the measurement. Now, do you think let's talk about the sample size, right? Was 2 an appropriate number, or 4 in the forest? Was 4 an appropriate number in the grassland for the number of measurements you averaged?
Probably not. Probably would want to do a lot more, I feel like.
Yeah, you want to do enough until the data you get doesn't change. So there's a sample area curve, and I'll post that in the discussion, but it basically, looks like a curve where there's exponential growth and then it levels off. And so if you continue to add new plots and nothing changed about that number, that cumulative average, you would say, I've measured enough. No new data is being discovered. Likewise, if you cared about the species, you would do the same thing. You would just look in the plot. You could use this plot without the crossbars, right? So if we didn't use the construction fence, we just used the white part, you could lay it down and say how many novel species are in this square, like how many different unique species there are. That would be the richness, how many different species there are. And you would do the sample area curve in the same exact way. You would continue to measure until you didn't find any new species. And then you would decide that you had measured enough. And again, you would start with a plan. And then the data would tell you if you should alter the plan. And the starting plan would be informed by the literature. You would find out what other people had done. And I guarantee you there's some benchmark that says how many you should do. And then you go with that. And that's even in qualitative data. So like in a case study, right? The number of cases that you might want to include in the case study would be something you would try to figure out based on the literature.